did you graph a point first? Did you graph this point first? Do you remember?
-6, yeah.
Now, is it clear why that's the first point to graph or
The
not?
vertex.
It it's actually, so if we were to add 6 to both sides, which maybe sounds really backwards, but and instead of g of x, I'm going to put y, and this was y plus 6 equals -1/3 x minus 5. This is in what's called point slope form. And the best way to graph these is to use the point x1, y1, which in your problem is 5 comma -6, which is that point right there. And then you use the slope from that point. Now, if that's not clear, there is another way to do it, although I think this is probably the way it was intended, was for it to be in point slope form like this.
Yes.
So do you, is that clear? Do you want like more explanation on that or?
Yeah.
Okay. All right. So then from there, you have your slope. You know that the slope is -1/3, which means down 1, right 3. So from this point, you're going down 1, you're going right 3. And then you don't really want to go backwards. So you kind of, the way I describe it is like, you try to figure out, well, where's the point such that when you go down 1 and right 3, you get to this point, and so on. And so you graph a few of these, get your ruler out, and hopefully, it looks reasonably straight here when you graph it. Is that okay?
Yes.
Okay. The other function is, I would do it slightly differently maybe than you are doing here. It looks like you're doing like transformations or something. Do you remember from class?
I don't.
Okay. So I think it's better to kind of remember, like, what can you actually take the square root of? Like, you can't take the square root of everything. You can take the square root of certain numbers. Like the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. You can only take the square root of certain numbers. So I would make a table. And in that table, I would try to figure out, well, what number does x have to be such that I get 0 in here? Like, what number would x be such that when you add it to 4, to subtract, like what do you add to x to get back to 0? And it's -4. Okay, so like -4 plus 4 gets you back to 0. The square root of 0 is 0. That's one way to do it. What do you think of that approach? You like it, dislike it, not sure?
I like the making a chart more.
Okay. So the next number here in the x, we have to get to 1. So like, what do you put for x such that when you add 4 to it, you get to 1? Can you tell me what that would be?
Um, -5.
-5 gets you to -1. We want to get to +1. So -3 would do it. Okay. And then to get to 2, what number would go here such that when you would
-2.
-2? And then the last one here would be, we want to get it to, I'm sorry, I misspoke there. We don't want to, we want to be the square root of 4, that's 0. 0 plus 4 is 4. And then you get to 9, it ends up being 5. Okay. So now, and we probably want to show some work here. So in this first one, it's negative square root, -4 plus 4 minus 3. It becomes the square root of 0, which is 0. Negative of 0 is 0. So this becomes 0 minus 3 or minus 3 like that. Is that okay?
Yes.
Okay, for the next one, it's minus square root -3 plus 4. So -3 on the outside here. So -3 plus 4 is 1. Square root of 1 is 1. becomes -1 minus 3, which is -4. So the next one is minus square root of 0 plus 4 minus 3. Why don't you try that one for us and tell me what you come up with here?
The -19. Or hold on, no.
Like it's much smaller than that, and add the numbers, take the square root, then negate it, then subtract 3.
What is -4 squared?
We're not squaring. It's this is the square root of 4 negated. Square root of 4 is 2.
So -1.
-2 minus 3. They're both negative. So that becomes -5. Okay, let's try this next one together. It becomes minus the square root of 5 plus 4 minus 3. Okay, so this is all for that one. The first, add the numbers inside. Then you're going to take a square root.
So 9.
And what is the square root of 9?
3.
Okay, so
3.
it becomes -3 minus 3, which is
0.
okay. It can't be 0. I mean, look at the previous
Oh,
one. It's -2 minus 3.
negative.
-6. Yeah. Yeah. Okay. So we probably should do another problem like this, but now the next thing is to go and plot these points. So starting at -4 minus 3, I'm going to do it in red just to kind of make it easier to see. -4 minus 3, it's here. Look at that. There's an intersection point. And then -3 minus 4, like that. And then 0 minus 5. And then 5 minus 6. So it actually hits in 2 places, which is kind of, I'm sorry, it's, well, looks something like that. All right, so I really feel like we should maybe do another root example or two. Is that okay with you?
Yes.
All right. So the intersection points, just to be like fully get the answer. The intersection points are here at -4 comma 3, and then at 1. Well, it's not there. Sorry, there. The other one is hard to find. 5, -6. Yeah, 5, -6 is the other one. Sorry. Those are the 2 intersection points. If you need those, you probably do.
Okay.
But more importantly is this whole like square root thing. So let me just dial it back, like give you a much more straightforward problem here. Let's just say the function is negative square root of x minus 3. Okay. We're going to build a table to do this. X, y, 0, 1, 4, and 9. Okay. So what you have to do is you have to put each of these x values, back in. Okay. So for the first one here, it's minus square root of 0 minus 3. Can you simplify that for us, please?
-3.
It's -3. The next one is minus square root of 1 minus 3.
-2.
Okay, so this becomes -1 minus 3. -1 minus 3. They're both negative, which means that,
-4.
yeah, you keep the sign, add the numbers. Minus square root of 4 minus 3.
-5.
And then can you do the last one for us, please?
-6.
Yes, very good. Okay. So where this gets more difficult is when the part inside the root. So let's go to the square root of like x minus 1, where the part inside the root isn't like exactly x, because like we can only take the square root of certain numbers. So we have to make the part inside the root equal to those certain numbers. Like if you put 0 in here, the problem is that 0 minus 1 is -1. That's bad. So what number should x be such that when you subtract 1 for it, you get 0?
1.
1. Very good. Okay. Now the next one we want to get to is 1. So how do you get to 1? Well, what number minus 1 gets you to 1? That's 2. What should the next number be to get to 4?
5.
5. And then for 9,
8.
8 minus 1
Or
is 7.
10.
There you go. Okay. I want you to fill in the rest of this table for me, please.
Is it 2, 3, 4, 5?
And you might be wondering, does the output always kind of go in this order? Yes and no. I mean, like for some of the problems it will. You should see sort of a trend here, but may not always be exactly that. So can we do one more before we move on, or yeah, why don't we do one more? Let's just do one more. So this one, let's go -2 square root x um, -2, no, +2. Let's go +2 this time, -1. And then again, it's always good to kind of go off to the side here and remind yourself, what can I actually take the square root of? So what x value gets you to 0?
Um, -2.
-2, good. -1, this is 2, and this is 7. Okay, very good. Now, let me show you the first one here because this one's just a little bit different. It's -2 square root of -2 plus 2 minus 1. So you do what's inside the root first, becomes the square root of 0, which is 0. -2 times 0 in here and ends up being 0 minus 1 is -1 like that. All right, so let's do the next one here. -2 square root -1 plus 2 minus 1. So this part becomes 1. The square root of 1 is 1. So it ends up being -2 times 1 minus 1. You multiply before subtracting, ends up being minus 3 like that. So why don't you try, the next two, please?
Okay. Is it -9 and -11?
Good question. Let's see. The first one is -5, and then the next one is -7. So let's take a look here. So it's -2 square root 2 plus 2 minus 1. So that's 4. Square root of 4 is 2. It becomes -2 times 2 minus 1. -4 minus 1 is -5. Okay, and then this last one here is -2 square root 7 plus 2 minus 1 is -2. So the square root of 9 is 3. That's where that goes. Ends up being -6 minus 1 or -7 like that. So notice it doesn't go up by 1 or down by 1. It goes down by 2 this time. So there is a pattern, but it's not, you can't just always say. All right. Do you want to do any more of these or move on to the factoring from Monday?
Um, Factoring. Or one more of these.
Okay. Let's go h of x equals negative square root x minus 3 plus 2. So I want you, well, we can do it together here. Let's fill in the tables. 0, 1, 4, and 9. I want you to tell me the 4 x values that go here.
The 3, 4, 7, and 12.
Go ahead and try. Do the first one and let me know your answer. And then then we'll decide if we can do the rest. Probably can.
Is it 2?
2. Good. All right, so give the next ones a try, please.
Is it negative? Or yeah, 2, 1, 0, -2?
It goes down by 1. So the last one should be -1. So let's look at that one. Square root of negative square root of 12 minus 3 plus 2 becomes minus the square root of 9 plus 2, which is minus 3 plus 2 or minus 1, like that.
Okay.
Any let's move on to some factoring here. So there is, before we even can do the problem they give you, we need to talk about this thing called difference of cubes. This is a very specific type of factoring. It's a higher order factoring. So there is a formula here for it. Hopefully you saw this in class. Something like that. And you typically get like a reference sheet on your tests or quizzes?
Yes. Sometimes we do.
Okay, this is a tough one to remember because it looks like there's a lot there, but keep that in mind. So let's do an example here. Let's say it's like x cubed minus 8. Okay. So the goal here is you have to turn it into something cubed minus something cubed. So the first one's not too bad. Like it's just x. X to the power of 3 is x cubed. But what do you put here such that when you multiply it by itself 3 times, you get back to 8? It's a number. Is my question clear, or do you want me to kind of explain it differently?
Yeah, I'm confused.
Okay, so 1 cubed is 1 times 1 times 1.
Yeah.
3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4 times 4, which is 64. The one I've not done is the answer. 2 cubed is 2 times 2 times 2, which is 8.
Okay, that makes sense.
Okay, now, so the idea here is that the x is really the a and the 2 is really the b. So now you just rewrite it where you put those in for instead of a and b. Okay, so it would be x minus 2, x squared plus x times 2 plus 2 squared, like that. So this becomes x minus 2, x squared plus 2x plus 4. Is that okay?
Yeah.
All right, so let's look at another one here. You're in pre-calculus, algebra 2?
Yes.
Which one?
Um, algebra 2.
Okay,
Or college algebra. I don't.
algebra, okay. Good enough. I'm just surprised that they're doing this. So next one here, let's do another example here. Let's say it's y cubed minus 64. Okay, so again, you got to figure out like what is it cubed minus what is it cubed, and I think it's really good to write it this way where it's in parentheses. So what goes in the first parentheses? What goes in the second parentheses?
Is it y and 8?
So 8 cubed is 8 times 8 times 8. So 8 times 8 definitely gets you to 64, but times another 8 gets you to 512, which is way.
Is it 4?
Yes. So yes, that's correct. So the y is your A, the 4 is your B. So this time it would be y minus 4. Again, we're just putting those in for the formula. Y squared plus y times 4 plus 4 squared, like that. Y squared plus 4y plus 16 is your. All right, now let's do another example. It doesn't have to be that the variable always comes first. So in the next example here, let's do 1 minus, let's just go p cubed, okay? And sometimes it can look like it's not difference of cubes. You're like, wait, what is this? But 1 to any power is always 1. So you can rewrite this as 1 cubed minus p cubed, like that. And so let me grab the formula here. Again, it's good. It's good when you're learning it to rewrite the formula every time, even though it's very tedious. It's a really good idea. So this is 1 minus p, 1 squared plus 1 times p plus p squared, like that. And then you can simplify. Okay, let me know when you get this down, or if you another
I got
if you
it.
got it. I want to give you one to try now. Okay.
Okay.
All right. So let's say it's 125 minus x cubed. Okay. And if you have questions, please ask. How are you doing on this one?
I got 5 minus x, and then in the other parentheses, 5 plus x squared.
Okay, but what is the value of A? What is A in your problem?
A is 5.
Okay, so you have to square it. And then you have to multiply A times B. Take another look at that.
So 25 plus and
Good.
then 5x plus x squared.
Good. Very good. Okay. Right. Now, the other types of problems you'll see here is where, and then we've already done one like this, like 8x cubed minus 27y cubed. Okay. So it's possible for it to be more than just a number or a letter. Like you have to figure out here, like, how do I get back to 8 when you cube it, which is 2? And how do you get back to x cubed, which is x, 2x? Okay, so 2 times 2 times 2 gets you to 8. X times x times x gets you to x cubed. This whole thing is now your A. Your A is 2x. And your B, why don't you tell me what B is? What goes in parentheses here?
Is it 3?
3 gets you back to 27, but what
3.
about, yes, yes. So now when you do your whole, like, okay, it's A minus B, A squared plus AB plus B squared, like that becomes 2x minus 3y, okay? But this time, A is more than just one thing, so you're squaring the 2x. So yeah, the 2x is in parentheses now squared,
Yeah.
plus 2x times 3y, you're multiplying those, plus 3y squared, like that. Is that okay?
Yeah.
So there's a bit more now to do to simplify it. You gotta square this thing, so it becomes 4x squared. You gotta multiply, that's 6xy, and then 9y squared, like that.
Okay.
Any questions on that?
No.
Okay. So let's go to your problem now. And you actually already kind of have the first step, which maybe we should talk a little bit more about GCS, but we'll do that in a moment here. So you correctly said, okay, I can factor out an x out of both of these. So it's like you have your x times 1 minus 64x cubed. So this 1 is something cubed minus 64x cubed is something cubed. So you have to figure out what goes in parentheses here. What do you cube get back to 1? What do you cube to get back to 64x cubed?
1 and 4.
Well, 1 gets you to 1, 4 gets you to 64, but not x cubed.
X 60 or 4x.
Yeah. So 4x, good. So this is your A and this is your B. Okay. So do you have the formula written down?
I do.
Okay. I want you to try working it out here, this A and B. I know you've got it there on the page, but maybe you can not look at it and try it fresh.
Okay. Is it 1 minus 4x in parentheses and then 1 plus 4x plus 4x squared?
Yeah, but go ahead and square that last one. What does that become?
4x squared or square? What were you?
Well, we just did a couple, right? Like you write it in parentheses with the square, parentheses with the square. Then you have to simplify. So like, how did I go from 2x squared to 4x squared? Well, you square the 2 and you square the x. Same thing over here on the right. We squared the 3 to get 9, you squared the y to get y squared. So in your problem, yeah, it is, but like what is that reduced to? What's the
16x squared.
good, good. And then you bring down this x like that. Okay. Let me see if I can find a couple of practice problems that are kind of like this one. Let's see here. Uh, okay, let's do this one. Actually, I'm gonna just write it fresh. Okay, let's say it's a 8a to the fourth plus 125a. Okay, so this is similar to your problem that you were given in class there. What can you do here? Do you see a GCF? Do you see a greatest common factor that goes in both 8a to the fourth and 125a? Could be a letter, could be a number, could be both.
A.
A goes in for both. So you divide both by a, it becomes 8a cubed plus 125. And what you want to do is basically like that a is just off to the side. Like it's going to be part of your answer, but you would just ignore it for the moment. You got to figure out what cubed plus what cube goes next here. So what goes in parentheses? Excuse me.
2a.
Good. And
And
for the other one?
5.
All right. So now this is your, what I'm calling big A, and this is your B. So could you tell me what the, oh, sorry, this one's slightly different. I didn't mean to do that. Let me put the negative in here. That was not, I did not mean to do that. That's confusing. We'll get to that in a moment. Okay, give this a try, please, for that difference of cubes.
So the 2a minus 5, and then 4a squared plus 2a times 5 plus 25.
Right. Give me the simplified of that little one.
Is it 10a?
Yeah. All right, so that's good. And then the only other thing here is you bring this A, down to be part of it. Okay. Now, I kind of alluded to it here. There's actually two different formulas. There's difference of cubes, which is what we've been doing. And then there's sum of cubes. All right, so I want you to look at the formulas here, and I'd like you to just tell me what you see that's different or the same about them.
The signs. The first
Yeah,
one.
so like at first glance, as a student, you might be like, "Oh, I can't remember this." But if you recognize, like, oh, the minus sign, see how that's the same, see how these are the same, and then the only difference is then that this is opposite.
Yeah.
You might find that you can actually pretty easily remember this. So we got enough time here. We can do another problem here. We'll keep it pretty simple though. Like, let's see here if I could find one. I don't know. These are all about the same. All right. Well, let's just say I give you something like um, 27x cubed plus 1. Okay, so this is now sum of cubes. You still have to figure out what cube plus what cubed. Can you tell me what goes in parentheses, please?
3 and 1.
X and then 1. Yep. All right. So use this formula here and see if you can come up with the sum of cubes.
The 3x minus 1, and then
Nope. No, it can't be because it's plus. It's plus. That's the whole point. Like this is a sum
2x
of cubes.
plus 1.
Like they're really grading you on your ability to put the right signs in. So that's why it's so important. Yeah, for sure.
And then 3 or 6 or so 9x squared, and then minus um 3x plus 1.
Really good. Excellent. Okay. I think we've got it. So do you feel better about these two topics?
Yes.
Excellent. All right. Let's go ahead and I don't see anything else that we can cover.